Hey guys. So we're starting a little bit early again this time, and I need to look over here. It's 9:08. Windows 11 for some reason doesn't show the time on all of your screens, just on the main one. Stupid. Anyway, hey guys, how are you guys doing on Christmas Eve? Huh? I thought, since we're all in lockdown and everything else, not much else to do, and so let's stream and build a board. Let's see who's here. Johnny Bergdahl is here, of course. And Maiko, Jeff Hammer. Happy holiday times. Happy holiday times to you too. 3:08. What? We're all in different time zones, of course. You celebrate Christmas today, actually. Oh. Yeah, not much going on Christmas Eve here in the Netherlands. It's either watching me, which is the obvious choice, or All You Need Is Love, which, yeah, I think I'll solder some boards. So let's see if, audio's a bit hot, I think. Let me tone that down. Right, yeah, okay. How is the audio and video? Is it all looking well? All you need is, soldering boards for Christmas. Audio good. Nice. I don't do Christmas. We'll be ripping out my manky old bathroom instead. Oh, that's something different for sure. So, I hope I solved the crashing issue with this PC. I replaced the memory, actually, because I still had another kit lying around. And so far, thumbs crossed, I don't know, whatever. It's looking good, but I haven't streamed for like 3 hours yet, so, well, we'll see what happens. Hope that doesn't sound double. Oh, you do Christmas. Okay. Goedenavond. Hello, Nicola Delino. Well, there's not many people here. I guess that is the effect of Christmas, huh? Let me spam it on my Discord at least. I need to get a link. Where are you, Discord? Announcements. There we go. Okay, Discord away, otherwise I get distracted for hours again. Got a new PC to build Boxing Day. Cool. Quick question before you get into it. 3 times 30 LEDs per meter WS2812B, what thickness of power injection is needed for 100% brightness? Would you believe me if I told you I actually didn't know, but Past Quindor does know. So let me link Past Quindor, because there is something called the Power Injection Livestream, and it guides you through exactly everything you want to know. So amount of total power draw at 100% RGB white, then how many power injections you need, where those need to be, and then what cable thickness those power injections need to be. So watch that video, at least 30 to 40 minutes, and you'll know everything. Past Quindor was great. He was very smart. Just the true believers here with the jolly guy. It turned up red on Discord. What? Anyway. Hey everyone, Merry Christmas, says Sevag. Ho ho, greetings from Almere, says Ron. Goedenavond op de kerstavond, says Johan. There's lots of Dutch here. I guess we're all stuck down in the lockdown, so nothing else to do but watch Quindor. More Dutchies incoming, yeah. Oh, the notification dot. Okay. No clue what they're talking about. Merry Christmas. Thank you for all you do. Thank you very much, Yummy. Hope we're going to get some yummy food tomorrow. We're going to do the typical Dutch thing. We're going to gourmet. Me and the girlfriend. And that's basically where you get a plate or a little pan. And you fry little tiny pieces of meat or vegetables or whatever in it. And then you eat it. And then you do that for a few hours. But it's great fun. Hey Quindor, in the WLED Discord, I noticed quite a few people come in after buying Dig-Quad suggested from the hookup. They had no idea about your wiring diagrams, etc. on the site. Yeah, I keep directing everyone I can to the website because there's loads of information there. But some don't find it and some don't look. Just direct them there and hopefully they can figure it out. Love my new Dig-Uno, says Andrew Malman. Nice. UK here. Oh. Yeah, Harvey. I'll check to maybe change the link because I have actually been making changes to the website, and we can look at that as the first thing today because it's time. We're officially allowed to talk about official things. So let me prepare that real quick. Let me do this. Okay, let's go to this guy. And then... there we go. I just need to make this window slightly bigger. There we go. So, if you look on the QuinLED website, which is very zoomed in, there is sections for analog LEDs, which we're going to talk about today. Or actually, we're going to build a controller for that today. And then there's digitally addressable LEDs. Now, normally, if you'd go here, there'd be lots of articles about all the boards. But what I've done, I've put them all in their own section. So if you're looking for the QuinLED-Dig-Quad, you go here and there's a little description of the board and of course a photo, but then all the articles are below here. So all the articles that were before were on that main page are now on this page. So if you're looking for the wiring guide, you go here and you find the wiring guide. But now if you I need a Dig-Uno, okay, fine. All the articles for the Dig-Uno are over here. And the same goes for the analog LEDs. All the various controllers now each have their own section with their own board article index, basically. And another thing I did, if you go, for instance, into the hardware guide, all the pages now say back to index page, which brings you back to, well, that board's index page. So I've put in a bit of work the last few days to try and update the site and make it a little bit easier to navigate and to find stuff and things like that. So hopefully that works out and more people are able to find the right stuff. But today we're going to talk about, or actually build, this guy. So this is the QuinLED-An-Penta. It's a board, the most recent design boards for analog LEDs that I did. And it's a 5-channel board that is very high power, has onboard fusing, runs on an ESP32. And it has a lot more elaborate circuit to do the analog PWM regulation than my previous boards. And this board basically does everything the right way. But because of that, it's a lot more involved. It's a 4-layer board, for instance, and there's lots of SMT on there. And, well, there's certainly some changes there. If we take a look at the board, I thought it'd be fun to run through some revisions, because this was the first revision. This was still a 2-layer board, didn't have all the functionality I wanted it to have in there. Wait, it needs to go this way. It did have the 2 fuses, and it had a clunky voltage, a DC-DC regulator here. The ESP was on the wrong way, and, well, this kind of worked, but it was never great. And then I moved on to, let's see, which version do we have here? Well, these are both the same, so let's take this one. Then I moved on to this version. This was version 0.72. And this already looks more like the final revision is starting to become. So it had the MOSFET drivers, and it had the spots for the MOSFETs, and much more outputs and inputs and stuff like that. And then the latest revision is this guy, because it's 0.74. So these were all still beta releases for myself and prototypes for testing and stuff like that. So layout is kind of the same, but internally a lot of stuff changed. There's some bodge wires here, as you can see, and I melted some terminals, and yeah. But lots of testing been done on this board. And what if you run out of versions before version 1? Yeah, then you're doing your versioning wrong. But this board is fully functional the way I'd like it to be, but of course it has bodge wires and all kinds of other crap going on. So today we're going to work on version 1, release 1. And let's hope that will be the final release. Because, well, here's the PCB. No, this way around. Okay. This is what I hope will be the version I can release. I have pre-released this to some people on Discord already who have ordered the PCBs and will be building them themselves. But a lot of information I've already published. So if we go back to the QuinLED-An-Penta index page, which is in the analog LED section, you see that we now have a specifications page, a hardware guide, a soldering guide, a pinout guide, and board dimensions, ESP home example configurations, and WLED configurations, because, well, the board is able to run both. So, and if we check out the hardware guide, we can see a component list. Now, this board, as I've mentioned before, is very different DIY than my previous boards. This is certainly more advanced DIY. You kind of need a hot plate for it, and most of the stuff is SMT, and there's a different way to build it and stuff like that. So, but there's lots of stuff you can order here. Most of the links go to LCSC instead of Aliexpress. There is still some stuff from Aliexpress, like the voltage regulators and things like that, but so the link to order it isn't public yet, but I have completed the guide on how to order the PCBs, and you need an SMD stencil, for instance, and stuff like that. And, well, there's some talk about additional hardware you can get, like an optional OLED screen for status display. You have much more choices in MOSFETs than you did before. You can change the brightness of the power LED. Well, lots of stuff you can do. And, well, the soldering guide isn't much yet because, well, I haven't filmed that video yet, because if I do, it'll be with this version of the board. But what is here, which is very important, is the interactive BOM. And this is also what we'll be using during the build. Let me change that. So this, let me change it some more, because I want this. This will guide you. Oh, no, I didn't want to do that. Okay, bye. Okay. This will guide you through putting all the components on the board. So basically, if you hover over here, you see what type of component it should be, and then it highlights all the spots on the board. If I can get there without moving, it highlights all the spots on the board where you should place that component. And once you've done that, you take them off, and then they become green that you've done those components, and then you move on to the next components, and the next, and the next, and the next, until basically all the spots on the board are green, and you're done placing all of the components. So that's a very different way of building it, and it's less of a guide I need to make. I will be making a soldering guide video, of course, but it's a much easier system to place all the components and make sure you've got everything. And it also works in reverse. If you're like, hey, okay, I don't remember what component these are, you can just click on that component and it'll show you what that component should be. It's just, that's so awesome. I love it. And even if you want to troubleshoot, if you're, for instance, okay, which pads or pins or whatever are VCC in? Well, okay, these are VCC in. Or which are, let's see, do we have ground here? Which pins are ground? Well, these pins on the board are connected to ground. Or which is FET2 or FET2H or FET1 out or 5 volt in, so you can see which pins should all get 5 volt. So it's very intuitive in what you can do without having the PCB files themselves, because again, I won't be sharing those for this board, but there's a lot more information you can find and use to well, build your own. So there's more pages. There's the pinout guide, and this board basically uses all the pins that are available on an ESP32. So first we have the power terminals, then we have the logical pinout, which is a lot, and then if you use Ethernet, these pins also get used. So yeah, lots of stuff going on, but yeah. So a lot of those guides are already available, and the URL is pretty simple: QuinLED.info/QuinLED-An-Penta. I mean, yeah. And well, today we'll be using the soldering guide and the interactive bomb to build it myself, because that's what I do. I also use the interactive bomb to build stuff. So let's see what chat's doing. Merry Christmas, says Unexpected Maker. Hey there. When would you use this versus a Dig-Quad? Maybe it's a better thing for things like kitchen cabinets and etc. than addressable. So analog LEDs are always going to be better, or currently there are no digitally addressable LEDs which have a good CRI value, so a proper good white light. So especially in your kitchen, if it's for main lighting purposes, so lighting a surface or whatever, where you actually do work, and not accent lighting, a good CRI value of at least, I say at least 90, but yeah, is preferred. And especially if you're using high power strips or lots of strips, or you want Ethernet connectivity or something like that, the An-Penta does things differently than my previous boards. And as I said, this board basically does everything right. So it has onboard fusing. It's very robustly built. Yeah, it's not like the other boards are bad, but those are very much oriented towards a simple DIY design, and this one is oriented towards, let's make the board I'd like to build and have the features that I'd like it to have. So it has 12 volt MOSFET gate drivers and stuff like that, which, well, the others don't, and that kind of limits the amount of power and the heat generated and stuff like that. So yeah. Well, main uses white lights. You can also use RGB, RGBW, RGB, CCT, whatever. You have 5 channels. You can divide however you want to. But the power side of it is definitely designed against running multiple high power, so 28 watts per meter white LED strip. But you can make it do anything you want. So Inkeber, this isn't the board you want to start with probably, unless you're very experienced with soldering and building stuff and things like that. It really depends on what you're looking to do, but yeah. Oh, Emil Bart's fiddling with LED effects. Nice. No, these are currently not assembled, Sion. These are a full DIY project. And this is also the DIY version. There will be a pre-assembled version, but that will basically be mostly a redesign of the whole board before I make that available, because this one is meant for DIY making. So it uses 0805 and other large components and stuff like that. And if I make it specifically for machine assembly, which you know everything about, you kind of design things differently. So yeah, this is an advanced DIY board. Yes. So yeah, today we're gonna be building this guy, and I got it nice in nice PCB way, glossy black, not matte because I didn't want to pay for that. And I got a nice E-Nick coating on it because, hey, it just looks fancy. So let's see if I can get maximum zoom here. Yeah, okay. So let's hope that's close up enough. I can always do some more digital zoom. Digital zoom. But yes, let's see. The first step would be to get our stencil. And actually to get a fresh board, because this one has grease all over it because, well, I've been clawing at it the whole time. Come on. Yeah, so now, of course, the camera is way too zoomed in to see anything. But this is the a stencil. That is a metal, a thin metal sheet you can order with your PCB, and that has laser cut holes for everywhere that paste needs to go. And for my previous boards, you could do without, I guess, in theory, because I mostly use 0805 and stuff like that components. You could do without on this board too. But I really wouldn't advise it because there are some smaller components on there and you really won't be able to do those correctly without a stencil. So this is a stencil. So it has all the holes that, as I said, need paste cut out. There's all kinds of wood fibers on there now. Okay. Now Sion's gonna cringe on how I apply thermal paste, but it's the best I got. Okay, let me zoom that camera out a little bit for now. This board still has some old design that never made it to production or sharing or whatever. But the new board actually has some of the DNA of the old board in there. It's never a waste to design stuff. Okay. Let me remove these, because to be able to stencil it, you kind of want a level surface with the PCB itself. So these PCBs are old and prototypes and whatever, so I'm not going to use those. And what I basically do is I stick them in between there. Yeah, there will be a pre-assembled version at some point, but I've been making pre-assembled or for sale boards for a while now, and I thought, hey, let's do something DIY again, because I kind of also love sharing, and you know. So what you do is you kind of line up the stencil so that all the pads poke through evenly, and I'm just now noticing that if you have E-Nick finish, it's actually much easier to see if everything is poking through correctly, because it's a different color than if it was the metal finish or the hassle finish. Interesting. And what I try to do is I make sure that it's kind of stuck down so that it doesn't move when I apply the paste. Yeah, that's true, Johnny. Designing stuff is how you learn and, you know, get stuff to work in the end. Because, well, I just showed you already 3 different revisions that I did, which some parts have worked and some parts I didn't like or didn't work. So then I changed them. Okay, so I use an old credit card, or credit card style format. And then for paste, I upgraded to the good stuff. So this is some Chipquik TS391 LT. And I like doing prototypes of that because it's very low temperature paste. So if you make a bodge or an error somewhere, or you want to change something, or you want to bodge something, it's very easy to do that because this is low temperature paste. So if you want to reflow it again, it reflows much easier than like 250C paste or whatever, because if you only need 138 degrees, you have a chance you can reflow some stuff before you burn up all the plastic pins and connectors on the board. Yeah. So I just use a fairly decent amount in some of the spots. And I know this isn't the way to do it, but this isn't production. This is prototyping. And I believe I can get away with it for prototyping. Right, so then it's just making sure the paste goes into the holes. And especially like this guy over here, that is an SHT 30 or 31 temperature sensor. That has very tiny pads. So let's see if we can do this. Yeah, see, I can never get it in one go. So I'm just gonna go at it. I didn't use enough paste. Yeah, okay. So this is a very bad application of paste. See, I'll make a soldering video, and in the soldering video, everything will be perfect. Yeah, didn't do it right. Okay. So I didn't stick it down completely right, but I think it'll be okay. Yeah, I know. I didn't get enough paste. I know. But I don't have a jar to put it back in, so I'm kind of conservative. And I just noticed I don't have my paper towels here for some reason. I don't know why. I'll use this. That's fine. Because any extra paste, in my case, is just going to go to waste. I need to get one of those jars, but I don't use it often enough, I guess. But let's see what the results are. We can always paste another if we completely screwed it up. This wasn't my best job. We can make that work. That's fine. Yeah, Chip Quick is awesome stuff, and as I said, I like their low temperature stuff. So let's remove this real quick. Ow. Clean this off. So this isn't, these are all the things you shouldn't do when you do this in production. But this isn't production. And you know, the stencil will survive a few applications like this. It doesn't need to survive like 200. Okay. Now let me get this box out of the way. Ow. I hit my elbow real hard just now. Yeah, exactly. Yeah, low temp stuff is a real time saver and lifesaver, because in the past I've had to redo complete boards because I wanted to change something, but I just couldn't get the components to come loose anymore before it melted all the plastic connectors on the board, basically. And now, with a little bit of heat plate and then a little bit of hot air, generally you can get it to come off and stick back on there, and yeah, replace something if you need to. Oh. Okay, so working surface. Let's zoom back in and look at my horrible paste job. It'll work. It's 0805. It's fine. Let's see. Is this in focus? Kind of is. It'll be okay. So next thing we do, and I need to set up a view for that. Let me try and add the interactive bomb here. Window capture, I think. Okay. But now we need to make it so that I can still see and you guys can still see. Okay, so now you can see the component type and kind of where it goes on the board. I can't make that picture any bigger for you guys because then it overlaps too much. Of course, now the chat is gone. Let me think about how to do this, because I can't really put you over there because then I don't have enough working surface anymore. Oh, Philip is here. Happy holidays, Quinder, and everyone in the chat. Sorry I can't join. Good luck and the magic smoke. Yeah, we'll see about that in a few hours. Yeah, I guess I'm going to do it like that because at least then I can see it. And you guys can at least, I think, see the component name. Yeah, so now I need to see, because I didn't have a lot of time to prepare, if I have most of my components in here or not. So here's some headers. Okay. Temperature sensor, MOSFET, diode. So what I often do is I make boxes per project, and I can't really show you this on camera, but I kind of just chuck all components in there, and then before I start, I kind of sort which type, so a capacitor or resistor or a diode or whatever, and then when it says a value I need, I can easily get that from the pile. MOSFET driver. This is a resistor. PTC. Resistor. Okay. Great. Nice. Because you'll end up with a lot of tiny little bags like this. And if you get them from LCSC, each of them has a sticker of what is inside of them, basically. So I need to get some other stuff, because the first component we need is an 0805 16 volt 0.1 microfarad capacitor. So if you're unknown with these things, 0805 is the size of it, basically. 16 volt is what I deem it to be able to minimally support. So it needs to be able to handle 16 volt at least. Now generally 0.1 microfarad capacitors are 50 volt, but higher voltage on a capacitor generally is fine. It just needs to be able to do at least the voltage you specify it for. Hold on. Okay. So the reason I use a daughter board for the ESP in this case, the ESP doesn't have to go on the board, so the board can be a lot smaller, and it has less traces or board space wasted that I can use for power planes and stuff like that. Now this is a 4-layer board, but on a 2-layer board that's a lot more important. And in this case, you can get it with my custom ESP32 boards or a generic VMOS D1 Mini 32, that works too. But mine you can get with a board antenna, a external antenna, or the Ethernet version. And this board is also fully compatible with the Ethernet version. So you can even just buy it with the regular ESP or build it yourself, because this is DIY. And then later upgrade to an Ethernet version if you need that in a certain spot, or an external antenna version or whatever. So yeah, and also projects which have the ESP32 on there directly are generally a lot less DIY friendly than projects which just use components basically, because adding the ESP32 logic onto the board also means you have to add a lot more stuff, and things again need to be smaller often, and things like that. So that's why especially for my DIY projects, I generally use an external ESP32 board, because that's a known or given quantity, and we know that works, and you can get it in multiple variants and things like that. Yeah. So let's see, because oh right, I have some of these. Let me show you on the bigger cam. And these are 3D printed boxes which have certain value components in there. Let me show you on this side. Yeah. So this is my capacitor box for 0805, and this has all kinds of values I use often basically. And I have the same thing, but then for resistors. So this is a box 3D printed. You print them per little cassette here, and they kind of snap on there. And this has all kinds of resistor values I use often in 0805. And I have also one for 0603. I don't have one yet for 0402, but I might in the future. Not sure yet. So now, for instance, we need a 0.1 microfarad 0805. For that, I just have a box which has those in there, so I don't have to order those each time again. I do order for specific components for a specific project, and then I put them in the box with the PCB often if I'm doing prototyping. But for this kind of stuff, yeah, I just use the generic boxes basically. So in this case, we need 9. And in this case, I'm just going to cut it off the roll, because then you're left with a little, nope, wrong view. You're left with a little tape, and this has 9 of them in there, and I can just pull that off and, well, basically put them to the side. And 0805 is still pretty big, but you are going to need tweezers to be able to put this on the board. And mine are over here. Oh, right. Sion. If you don't have these yet, these are from Aliexpress. They're titanium tweezers, and I love these things to death. I've had this one for about 6 months now or so, and I've done many projects with them, and these are just excellent. I mean, after 6 months of building prototypes and stuff like that, the tips are still, well, basically immaculate. They're really, really excellent. They're like $7 or $8 a piece, but yeah, they're great. So yeah, Jordy, I either just tip the components out, or I cut a little tape if I need a lot of them, and then just, you know, take them out like I just showed you. So let me see where these all need to go, because we do need to kind of keep moving here. I keep looking at the wrong spot on my screen. So now it's just a question of looking at the red marked components on the interactive bomb and placing the components there. And they don't need to align perfectly. As long as they're generally in the right spot, it'll work. Especially with 0805 and these hand solder pads. Because in the design of the board, I actually took into account that this is DIY, so I made the pads much bigger. Or well, KiCad has a hand solder pad basically, which is bigger. Now I'm left with one. I don't remember if I have them all. No, I don't. Okay. Did I do that right? Yes. Ah, okay. I was going to say, I'm missing one, but I couldn't see my whole screen or my whole browser. There we go. Okay. Oh, thanks for linking, Johnny. Yeah, I don't have the time to look it up right now, but you can find them on Thingiverse for sure. Better have them in pink for Johnny. Yeah, I couldn't get used to reverse tweezers, so let's take these off and go to the next ones. And these are 1 UF. Now, that's also a generic value, and I need 5 of those. Okay. And those go right next to them. Oh wait, did I turn the music down? I don't think I did. Well, that's okay. Yeah, so this is the boring part, I guess. Because it's hard to entertain you guys while actually doing the work. Oh, we need a 50 volt 10. I think that's a... Oh, no, we need a 10 volt. 10 volt I have over here. And that goes right there. Yep. Okay. Okay, so this is the big capacitor that goes over here. And we're going to skip that for now. We're just going to do the SMT parts first, and then we'll do the through-hole parts later. And actually, that big capacitor is optional. So, okay. So we're moving on to resistors, and the first ones are 10K, and we need 5. Let's see where these go. Now, I'm not going to pay attention to the orientation. I am going to pay attention to if they're upside down or not, but people have OCD. Well, you can pay attention to that on your board. Okay. So normally when I'm placing this stuff, I actually move the PCB around a lot. But since this is on video, that's going to be tough. Okay. So I'm trying not to do that right now. Come on, let's go. Okay, let me clean this thing a little bit. Okay, already done. 6.2 ohms. Okay, so those are for after the MOSFET drivers. And that's not a value I use often, so. Quinler doesn't have OCD, he just doesn't want to see the world burn. Well, that's what the fuses are for, aren't they? Let's see, 5. 1, 2, 3, 4, 5. Okay. Okay, this one goes here. Right. Next, 200 ohm. I think those are special values too. 200 ohms. Now that is from the ESP32 pin to the MOSFET gate driver. The other ones were after the MOSFET gate driver. And that's all to make the curves of the PWM just a tiny little bit smoother. Yep. And these are all the stuff that the previous boards didn't have because, well, it kind of works without it. It's not pretty, but it works. And this board is more designed as in, well, this is how you kind of should do it. Right over there. Okay, for this one I do need to move the board a little bit, because otherwise I'm just going to break my arm. There we go. Okay. Next, 3K. Again, I don't think that's a normal value. And we have those in a little bag. Let's see here. We need 5 big surprise. 1, 2, 3, 4, 5. And as you can see in the interactive bomb, or maybe not, but you can see it if you open it yourself. You can actually open it yourself and follow along. They're all on the. It's publicly available on the website. But all the LCSC links for ordering the parts are right in there. So they're in the table in the hardware guide, but they're also linked in the interactive bomb. Because there you can also tick off that you actually ordered the part and kind of keep track. And do keep in mind that some parts have alternatives listed in there. Oh. For the ESP32, for instance, you can get mine or you can get a generic one. And some parts need 2 components because we're using pluggable terminals. So they need the piece that goes on the board, and then they need the piece that you plug into that. So keep that in mind. Let's see, 1K. 1K sounds like a generic value. Yes, it is. And I need 3 of those. Let me try and cut that off. And of course, they flew everywhere. That wasn't very smart. So I have some here, but I need to check if they're the right value. Let me get my enhancements. Enhance. So these are 201, 201, 201, 301? What's a 301? Well, I guess I could look at them on camera. Barely. But this is a 301. That's a 3K then, I'd imagine. Can I show you like that? Huh. So 102, but we need 3K. No, we need 1K. Okay. So 103 is wrong, I think. I don't know. Let me check what's on the reel. Yeah, the reel with 1K also has 201s. So we need these 3. Merry Christmas, Nicholas. Got carpet. No, I don't have carpet here, but it'll go into the vacuum at some point. So these are for a hardware debouncing circuit if you attach a switch or something like that. Again, it'll work without it, but it'll work a lot better with it. That's basically the idea. Let's see here. This is a 4K. Now, this is for the power LED, so it's not gonna matter too much. I don't like very bright power LEDs. It is connected to 5 volt, so I'm just gonna use a 4.7K, although the data sheet says 4K. Using a 4.7K will just make the power LED a little bit dimmer, which I kind of like. There we go. Ah, and then we need an LED. Where do I have my LEDs? Or do I have it? No, I didn't have them here. I have a box named SMD LED. So what color do we want? I generally use... the first bag I grabbed is orange. I like orange LEDs. Do I have pink? Let me see if I have pink for Johnny. Hold on. Orange, orange. Seems to have a lot of orange. Oh, wait, here. No, this is 0603. Nope, sorry. It's going to be orange. Can't help it. The Dutch color, yes. But I actually just kind of like the color. Maybe because I'm old, you know, and when we began, computer screens and everything were kind of neon glow green or a very specific type of orange. And we used to have an Olivetti machine, and it actually had an orange screen. So maybe that's why I like it. I don't know. Yeah, I know. I'll order some pink 0805 and 0603 and 0402 power LEDs for when we're doing another build. So it's always, there's a little arrow. Oh, you can't see that. There's a little arrow on there, and that should point towards the little dot that's over here on the PCB. If I'm right. And I'm not always right. I sometimes get this reversed. Not so much on the board layout, but the dot is ground, and power should flow from positive, which is the resistor, to ground. So the arrow should go to ground. But sometimes it's still reversed, or you have a different brand LED, or stupid stuff is going on. But yeah, this should work. We'll see. We'll see. So with the MCP 1416, those are MOSFET gate driver ICs. So on the previous boards, which again were easy to build, we didn't have these, which meant that the gates of the MOSFETs, so the pin you triggered the MOSFET with, were tied directly to a GPIO pin on an ESP32. But that can only deliver 3.3 volts, and then with a very low amount of current. So the charge time for the gate, etc. was very high. Now this worked with very specific MOSFETs, but in this case we're using MOSFET drivers, and those can punch out like a few amps if it needs to, and we'll also be running them at 12 volt so that the 3.3 volt gate of the ESP triggers the MOSFET gate driver, and that then triggers the MOSFET gate itself at 12 volts. So, yeah. Yeah, Olivetti made some orange type screens, and I guess that's why I kind of like them, but... Now, these are also one of the smallest package on the board. The smallest one is the temperature sensor, but these are coming as a good second. But in my opinion, this type of package... Oh, no, don't do that. Is pretty easy to work with, actually, as long as you get the orientation right. Because you then just kind of just plump it on there. Oh, sorry about that. And then you maneuver into position, and you push it down, and it should align further than for the rest itself. Okay. Last one. Now I need to hang above the PCB a little bit, because otherwise I can't see it myself. Yeah, that should be fine. Okay, these are all through-hole things. ESP, again through-hole. Ah, the dreaded temperature sensor. Now this bugger, it's really small. You see that U10 right in the middle of the board? And I kind of almost didn't do it because I thought, people won't like that for DIY. But then I was like, yeah, well, it's a temperature sensor. It's not vital to the operation of the board. So if they can't get that one right, it's okay. Now, we need to pay attention to the orientation. Let's see here. I did paste correctly, I think. Where's pin 1 again? There is a little dot there. Okay, I need to get my magnifying glasses out just to be sure. Right, okay. So, you can almost see it on camera. One of these corners here has a slight cutoff to it where the others don't, and in this case that means we need to align it like so. Oh no, I'm not sure I did it right. Yeah, like this way. So I'm gonna move the board again just to get it right. And what I generally do is I just drop it on there and I very gently nudge it into place. And I think that is about right, because I can see the solder on both sides and it's kind of aligned in the middle. That should reflow correctly, I think. The one is upside down. Which is upside down? Oh, you mean the resistors? Yeah, I don't care about that. Okay, fuse holder. Ah, PTC. We put that one somewhere over here. So this is a giant PTC because it transports 24 volts. Oh wait, this is a diode. Don't need those yet. Where did I put the PTC? There we go. Is this the right one? Yeah. Oh no. Okay, I use it. Oh, I showed it upside down. Yeah, that's right. Yeah, that's why I did my little flippy action. Okay, let's see if this PTC is a nicer side or not. It doesn't really. PTC orientation doesn't matter. And just clunk it on down there. It should have enough paste to, keep it there solidly. Okay, and then we get to the MOSFETs. And here we have a choice. I have the FDD8447L listed, but those are 3.3 volt gate MOSFETs, and actually most MOSFETs I have kind of work with a 3.3 volt gate, but then if you want to run more amps to it, or you want them to run cooler, having the higher gate voltage still helps, even though it triggers at a lower voltage. hitting it with a higher voltage will make it run cooler, basically. So that's what this board does. But we have a few different types of MOSFETs we can choose, actually. Because I have these, the LNG045R55, but I also have the LNG06R079, and well, then I have the FDD8447Ls, and I believe I actually have some more types, but I don't know where those are. Because I've been testing with them, but kind of the conclusion was they all work. So let's do some 8447s. Because I have some loose in the back, it seems. Okay. And then let's do, I don't know, 2 of these. Because I do still want to test with them, just to make sure. And there's seemingly one in the bag here too. Come on, okay. And let's do another one. Yes, my camera is mirrored, because otherwise it doesn't look the right way around, I guess. Hey, we've been streaming for an hour and my PC hasn't crashed yet. That's good. Yeah, okay. Right, this roll, okay. And let's use one of these. Wait, how did I not use these yet? Okay. I could just cut it off last time. There we go. Okay, here's the board again. Let me put it over here. And let's see, let's take our... I think I mixed up the types now. Yeah, so let's do our 8447 over here. And let's do the second 8447 at the channel below that. Ooh. Let me see which types these were. Right, then we have the LN45. And then we have the other LNs. I have these types listed in my hardware guide if you go to the additional information part. And as I said, as far as I've tested with them, they've been pretty good. Okay, this is a connector, this is a connector, connector. Okay, that means all SMD parts should be done. And if we look over here, let's see, is that true? Yeah, all SMD parts are showing green. That means the... is this the most challenging board you've ever soldered? No. My production models, so the pre-assembled models, they often use 0402 components and other smaller footprints, and those are much more challenging than what's on here. So no, especially like the Ethernet boards. I've built... Hold on, let me show you. Okay. So you see... No, you don't see, because the parts are in the way. You see these components, right? Those are all 0805 and stuff like that. And then there's these. Can I show you closer? I don't know. Yeah, I guess. So this is an 0805. Those are 0402. So 0402 is much Much smaller. See, that's a 0805 and an 0402 capacitor. That's a lot smaller, and it comes a lot tighter spacing, and there's almost no paste to, you know, pull the components to the right spot. And so, no, 0402 is definitely more challenging in that sense. Now, there's a lot of components, or relatively a lot of components on this board, but that's basically it. Otherwise, it's not that hard to build, in my opinion. Okay, so it's a reflow time, because we have all the components. Now, let me do one final check to see if most of the components are at least somewhat in the middle, basically. Well, it's looking pretty good. Yep, I think they'll reflow okay. Okay, let me make a little bit of space for my my fume sucker, because, you know, I'm a sucker, but not for fumes. Okay, and let me get my hot air. Or not my hot air. I also have hot air, but we're gonna use a little heat plate. And that's this little guy. I've shown it before. This is a little 10 by 10 centimeter heat plate. It can go up to 350 degrees, I believe, but since we're using low paste solder, I basically set it to 150, 155, and that reflows it perfectly. I have those in my equipment list, which is also linked in the video description. And if you do anything SMD, I can certainly recommend those. Now, let me see if I have a power cord here. I should have. Yes, I do. I have to make sure nothing gets knocked off the desk. Okay. And, well, in this case, I'm just going to put the board on there while it's actually already heating up. But I guess I can show you on camera. Okay, so now I can still pretty easily pick up this board and just put it on there. And then I'm going to put this here. And there we go. And I want this to kind of be close. And you want to be able to reach it still with the tweezers for when you need to adjust something slightly when you're reflowing. Let's see if I can get this kind of... I guess we can fully zoom it in. There we go. That should be able to show you the actual reflow action. So let me turn that socket on. Turn on the plate. Okay, the plate is set to 155 degrees Celsius. And, well, now it's time to... Well, I always wear my glasses. That's a personal thing. Especially when soldering, sometimes some flux can, you know, splatter somewhere. So now you get to see me with my, my glasses. Hey. I believe you have to move C2 and C9, okay? So C2 is a, what is it? Okay, so that's supposed to be one of these. This looks fine. No, those all look fine to me. Let me disable the parts overview. There we go. Yeah, so the one other advantage of this lower temperature stuff is it's not the official right way, but I can easily keep this board at 155 degrees for like a minute or two without frying any of the components. It's only when you go up to like 230 or 250 or above that, if you have other type of paste, that it becomes a lot more critical. But keeping them at this low high temperature, well, you have a lot more wiggle room to work with, basically. So we're now at 52 degrees. It takes a long time to heat up, but then it stays warm for a long time. And you can see like a C16 over here. You'd think like, that's kind of crooked. It won't matter. It'll pull that straight. How dare you not know every SMD component position on the board by memory? Well, I actually changed some stuff in the last revision, but I know a lot of them, and I can figure them out actually by looking at it. But if you have the interactive bomb, it's just so much easier. Oh right, maybe I should turn the suction on. So, Patricia, are you spamming or what? Yeah, surface tension will pull it. That's right, Johnny. First time I used a hot air gun, I blew off all the components from the board. Oh, yeah, no. Thanks, Johnny. So there's 91 people watching to what I would call akin to almost watching paint dry. We're watching solder paste melt. Indeed a spammer, yeah. At least if they write a little creative message or something like that, I wouldn't even mind too much, but just like stupid spam. 95 people watching. But I only have 23 likes. What's going on? Seen a lot of those actually. Oh, okay. So we're at 92 degrees. We'll almost see some stuff happening. $27 now. Nice. Okay, we're at 98 degrees Celsius. Oh wow, really? That sucks. Boring. 41 likes, 44 likes. Thank you guys. Have to keep the algorithm happy and me, but oh, we're at 105. Now this paste is getting slightly older. I might need to order some new soon, but should still work fine. Hey Bart, Merry Christmas to you guys too. Oh, Make Me Lab is here. Hi guy, hey there. Okay, we're at 112. Takes a little bit. Any second now. 116. An-Penta. It means analog 5-channel. That's it. Yeah, that's true. You shouldn't put it on a fully heated heat plate, because then it'll get instant heat at like a very high temperature. That's not good. This is a bit slow, but it's okay. It's all about the temperatures, and as I said, we're at 123 now, so we should see something happening soon. But we're only going up to 155. When will the toast be ready? Few minutes. And then we'll do the hand soldering. So this board is used to dim LED strip. So it's a PWM dimmer. You can use it wireless or with Ethernet. Connected to an app in a WLED, for instance, or with ESP Home and Home Assistant. And it's just a very open board you can use to do dimming on LEDs. And you can even use inductive loads, because I have spots for diodes and a capacitor on there. 133. We should be getting there soon. Yeah, you can see stuff moving. Yeah, it's going. Okay, we're at 138 exactly. Let's give it a little bit longer, because I always feel the need to start knocking components. Okay. So, for instance, we have this guy. And he could be neater. There we go. And then, let's see, we have this guy. That could be a bit neater. Nothing seems to be touching. Yeah, you can see the flux is still doing its work. So this should be good. Oh, there we go. That should be good. This should be pretty good. Now, I think I knocked it the wrong way. I think that's good, but I'm going to use my magnifier on that. Yeah, I think that's good. Yeah, I think we're good. Do you guys see any component I should give a nudge? I think they all look pretty good. So, what I do now is I turn the heat plate off and I leave it for a little while. Yeah, you're looking for non-shiny, non-molten paste, but I gave it a minute or so at 155, so I believe it should all be fine. So I turn it off, but this plate takes a very long time to cool off. But I do leave it for a little while. And what I actually often do is I take my fume extractor and I kind of point it at the top, like that. Because I've taken boards off of it before and then jolted or jarred the board while I had it in my hand, and then the components of course move because they're still molten, and generally when hitting them with a little bit of air like this, at least they'll surface mount basically. Not fully yet, but at least enough to stay stuck on there. Okay, so let me turn that off. Temp shock by removing it. No, if you don't temp shock it by removing it, but what I do is I generally slide it off and I tried to get a good grip on it with my tweezers. There we go. And then I put it down. And now I need to get rid of this hot plate because it needs to cool down at least half an hour or something like that. So let me put that over here. And there we have it, a reflowed board. Now let's just have this cool off a little bit while it's on the cork. The cork won't catch fire. But everything should already be stuck in place. There's a few solder balls I sometimes like to get off, sometimes I don't, but yeah, that's all looking pretty good. Let me recheck the temperature sensor, because if you still want to reflow it, you should do so now. No, I think that's good. Don't think you can see it like I see it, but let me try and find it. Yeah, you can't really see it, but I believe this is fine. Okay, so we let that cool down a little bit, and we can start looking at the other parts we need, because next to the SMD part, we also have a through-hole part we need to solder, such as the pin headers and all the just trying to wrangle a wire here. The pin headers, all the screw terminals, and the fuse holders, stuff like that. So let's get those. So we need 2 fuse holders. And then we need some pin sockets. So I think we need 2 of these. Yep. Then for the OLED screen, or if you want to use them as extra headers, we need a 7-pin one over here. Yep. Let's see. Oh, for the screw terminals, I need to get my my big box of screw terminals. Hold on. Almost there, almost there. I'm just sorting them out. Okay, I need a 5-pin. Those are complete. Now I just need a 5-pin, I believe. Yep. Okay. It's always a challenge to get these in back in the same way they went in, or at least in a way that the box will close. But don't think it's going to do that today. I'll look at that later. Oh, okay. Crumbly. Yeah, sorry. So, nope. So these screw terminals exist out of two pieces. This is a 5.08 one with 5 pins. So you have the piece that goes onto the board. You solder this to the board. And then you have the piece you screw the wires into. Now I like using these. I don't do so on my digital boards because that often deals with 5 volt. And these aren't great for huge amount of amps, or current basically. On here it's fine though, because generally you'll be using 24 volt or sometimes 12 volt. That will allow for a lot more power. So same thing, you have this which solders to the board, and then you just click those together. So let's see if we have most of the stuff we need, because the board is now easily cooled down. That's fine. So we can just slot these in and start seeing if we have everything we need. Now I don't use the I-bomb for this because I kind of know what goes in here. Okay. Right. Okay, that is all the screw connectors and everything we need. The only thing missing are the DC-DC regulators here. I believe I have those over here. And we need several of those. We need a 12 volt version. And then we don't need 9. 12. We need a 3.3 volt version. And we need a 5 volt version. Oh, there we go. And we need a 5 volt version. Can't see that. Yeah, okay. So we need 3 of the exact same, just to make it easy and saves on some of the components on the board, because if I wanted to lay this out on the board, well, you could of course with SMD, but then you'd need an even much bigger amount of those. Yeah, so these are They cost about 80 to 90 cents a piece, which is actually pretty good for a whole buck regulator setup right now. And as I said, you can get them in several different voltages. There we go. So let me line them up here. 3.3 volt, 5 volt, and 12 volt. Right? And those three are the three values we need on this board. Now we need something to put those in the board, because, well, we need some simple pin headers for that. So let me get my pin header thingy. And I'm actually wondering if I have the pin headers listed in the BOM or not. I don't think so. Because, well, you can use any generic 2.54mm pin header, and you just need 3 pieces of 3. Do you have a link by chance to those? Yes, I have a link to all of those. Check the hardware guide. They're in a table there. Or check the soldering guide. They're in the IBOM file there. And those all have links and everything. So these will go here. Okay, we don't need those now. And then later we'll solder these in the appropriate position onto those. In theory. Hold on. Like that. And we'll make sure they float above the other components on the board. But yeah. Now, there is an order to do this. And that is basically by starting with the lowest components first. Now, the fuse holders are the actual lowest components. But those will kind of stick into the board anyway. So then we can concern ourselves with all the pin headers and stuff like that. And here the cork surface I use again comes into play, because I can kind of use it to. I have the board here with the components on top. I put this on top and then I just flip it around while keeping pressure on it, and that generally helps keeping everything in its place and straight up. So let me get my soldering iron, and I don't know which tip is on here right now. Oh, okay. The reasonably fine tip. And the next tip then is to basically tin one of them, or solder one of them, and I need to start my air again. See, now I have a problem. Because I can't really move my air. Let's see if this works. Okay. So we just tin one of the pins, or we solder one of the pins. Let me get my glasses too. Okay. Because if we only do one, we can then later go back and straighten it out on the front. I always seem to hit the ground pin first. Oh, what happened here? Interesting. Anyway, so, okay. Now we tacked on one pin of each, and we can check on the front how everything is aligned. Now these seem fine. That's good. They don't lift off anywhere. Okay. This one seems fine and straight too. And it seems flush with the board. These two seem okay, but this one, it's a little bit crooked, I guess. So I'd like to adjust that one. So what I generally do is I hold the board, let's do it like that, kind of like that, so that I can push it with a finger, and then I can heat up that joint, kind of wiggle it the way I want it to be, and then see if that's better. Kinda is. It's okay. It's slightly turned this way. I think I can make that work. So everything else looks fine and straight. So then we can do all the other pins. Still using the damn pencil? What do you mean? No, this is the Eichstone T3A, and for these pin headers I like using this kind of tip. Yeah. Come on. Doesn't want to go. There we go. There we go, bridge gone. No, this isn't a chisel tip. I do have one, but especially for this next part where there's two rows, kind of like using this one. I have a chisel tip, but I mean, is it this one? No, this is the big, yeah. So I have this tip too, but for the double rows, I don't like using that one. Flux, yeah, I know, but often I can fix it. I'm also still using leaded solder. Now this is an advantage of having a 200 watt iron. You can just keep going, and you'll see later with the screw terminals, This thing has so much power. Oh. Come on. Come on. Oh, irritating. There's a little bit much on these. I think it'll be okay. Yeah, it'll be okay. Seems to be burning off that flux a bit quick. No, it's okay. It's at 350 degrees. That should be fine. But this soldering iron has heat loads of power, so... I hope I got most of those straight. Let's see. Looks pretty good. There's a few bigger balls here than I'd like, but nothing that's going to interfere with anything. And that's mostly the ground connections, so it soaks up a lot of heat. Okay, that looks fine. So let's start doing the bigger stuff. No, actually that's not. Because we need to start with the voltage regulators, or the buck converters. So there's a little dot on the back. This says 12 volt. So I'm going to put that in the... Oh no, I did it again. I shouldn't solder this header before I solder the voltage regulators. And I keep doing that on every prototype. It's not like it's impossible after that. It's just so much easier if I didn't do that. But it's not worth the hassle of desoldering either. 5 volt, yeah, 5 volt. There we go. What solder do you use? I have a giant roll of, wait. Alpha Telecore XL235 or 3. I think 235. Oh no! It'll expire in March, and it's restricted to professional users. Well, I guess I should quit my job. I don't know. Well, yeah, it's a tin lead cord solder wire. I like it. It's good stuff. It's not cheap, but it's good. Polish brand? I don't know who makes it. So, the trick here is to solder one of the pins without melting the plastic. Wait until it reflows. But of course it drops down then, and I generally just use my tweezer or something like that to kind of nudge it to where I want it to be. Hold on, this needs to go down. Something like that, and I just hold it down. Okay, that's solidified. And then it's actually, what I'll show you a bit closer, it's actually floating a little bit above the board, but you can bend it later a little bit if you need to, because we kind of want them straight on the board so that they don't touch the components beneath it. Now there's no exposed pads or components on it beneath it, but still. So let's solder the other pads. A little bit more. Okay, let's reflow this one. There we go. Guido says, I have some solder that most likely expired 25 years ago. Still works fine. Yeah, that's true. Okay, so let's do that for the other ones. But because I already soldered this header, that actually kind of makes it more difficult. But still. Okay, it just needs to take it on the pad, and then I can move it. Okay, and then I can verify it's okay. Yep, that looks good. Do the other ones, and then often I redo the initial pad too. Now this looks kind of difficult, and maybe it is. But especially if this stupid header, if you don't solder that on there first, it should be fine. And this one I'll do from this direction. Okay, well, let me fix this one real quick. There we go. That should be fine. There's a little bit much on that one. There. I moved it over the pin and now it's fine. You can see I kind of had too much solder on there, but I just brushed it up on the pin. So now it's fine, that's okay. So let's do the last one. So again, I tin one of the pads that I can reach easily. And then I can just take the board, hold it like I want to have it. And there we go. And then I can just solder the rest, but I'll do that from this side. Okay. Now these are pretty good. I'd like the middle one to be slightly more up, but you can just bend it a little bit. And now that looks fine. And as you can see there, let me see if I can focus that. Not really. But they're floating above the components below that, basically. So they're basically free floating in the air, and there's no hot components below there anyway. But yeah, I don't like things touching, so yeah, that worked out great. Well, it's been designed that way, but still. Oh yeah, I don't like soldering without the fume extraction. It keeps bothering me for a while otherwise. Is this lifted up? Oh no, one of the ESP sockets is lifted up. Oh. Okay, that sucks. This socket here, it kind of lifted up a little bit. I think it will still work, but yeah. Okay, so let's do the fuse holders. And after that, we will do all the terminals. Now the fuse holders, as I said, they're very snug fit. But I'll show you something cool about this soldering iron. Because the cool thing is, you have this base, and what you can do is, I want this tip to go in there, so I'm going to leave that there, and you can kind of hook the tip like that, and so it stays there, and then I can just hook it like that, push it in here, and now I have this different tip on my soldering iron, and it's already heated up, because it's that quick. because now we'll need a lot more power, and well, then you kind of want a bigger tip, and that's what we have here. Okay. Let's see here. Now these are planes that are connected on 4 levels, so you really want to soak some heat in there. So take your time, heat it up until you see the flux burning off, basically. And there we go. That's a good joint. That's a good joint. But for these, it really helps having a really powerful soldering iron. $200. Don't get one, Emil Bart. This one wasn't $200. Because this is a JBC clone, basically. Look them up on my equipment page, the Ixon T3A. I really like them. Oh, I put a bit too much heat into these, so the solder actually flowed into the fuse holder itself. Generally, that's not too big of a problem, but I'm going to add a little bit more just to make sure. Okay. Okay. So let me see if I can still use the fuse holder. I think so. Yeah, you see a little bit of solder that flowed into this little shoe here. Let me get a fuse. This one, for instance. So this socket should work fine. Okay. And this socket, oh, okay, still works fine. That's okay. As long as it doesn't flow between the shoes, you're basically fine. So, okay. That's all the pins and stuff like that done. So now we're going to look at doing the screw terminals. This one. Now, I haven't figured out a great way to do this yet. Of course, these you can't solder with them plugged in. Oh, and there was something I wanted to check. Because I made some extra space on the board for if you wanted to use regular terminals. So let's say I don't want a pluggable terminal here, but I want a normal screw terminal here. And it'll overlap the labels and stuff like that, but these do fit now without interfering with this one. And even for these are 3.81 millimeter. You should be able to get the screw terminal type, and they should fit on there together, basically. Now I like using the pluggable style, so I'm going to use those. But it should be compatible with both types now. Okay. These I can leave plugged, I think. Okay, so now I need to kind of figure out the best way to do this. Let me move the board over here. I think I'm going to have to do the one pin method again. Oh no. I screwed it all up. Okay. Let me try and fix it. Okay. Yeah, let me try and get that on camera. Okay, I'm gonna zoom out a little bit. There we go. Okay, so I'm probably just gonna solder one pin each time and then check if it's in there correctly, and otherwise push it in and then solder the rest, just to make sure. These big terminals give him plenty of solder. Okay, yeah, so okay, I want to move this one just so slightly. Okay, so that's now on there correctly. Same thing with this one. Just if you want, I mean, you'll get a good connection anyway, but if you want them perfect, this is the best method I know how to do it. You could also stick them down with tape or blue tack or something like that. Okay, so those are on there just fine now. Then I'll solder the other pin. Okay. Yep, those are good. Next, let's do the 4-pin over here. Same thing. Position it like you think it needs to go. Okay. And then line it up perfectly. Nope, still not good. Okay, that should do it. Yep, that's well aligned. And then do the rest. Now, it seems like these are very easy to solder. If I had used my previous iron, trust me, they would not be. I would be soldering one of those pins for at least a minute. But this thing just has this T3A IXM, just has an insane amount of power. Okay, next. Okay. Okay, that's on there flush. Good. How is everyone doing? Are we guys bored yet? Okay, that worked fine. So now it's only these 3 screw terminals and we're almost done soldering. So this is a bit tricky because they're lower than what we did previously. So I'm just gonna have to... Oops. I'm just gonna have to push down on them while soldering, I guess. And then hold the board. Okay. And then check how it's mounted. It's a bit up. Okay, that fixed that. And now it's flush on the board. Good. Okay. Next. Make sure that one's flush. Yep, that looks good. No, wait. Shouldn't do that pin immediately again, because now it falls out. Okay, make sure it's flush again. Is Quindoor Dutch? Ja, ik ben Nederlands. Very much so. Okay, that's all fine. Just a bit Dutch. No, not bored. Love this stuff. What is the temperature of the soldering iron? It's at 350 degrees. At 350 C or Celsius. But as I said, if I used my previous iron, especially for these bigger parts or these bigger planes and stuff like that, I would have needed to put it on 450 and keep it on there a minute. And this new iron is just so powerful with this big tip here. It's just wow, makes a big difference. Okay, same trick. Tack it on there. Make sure it's flush with the board and straight. Okay. Okay, there we go. Rip my TS100. Well, TS100 isn't bad, and it's able to deliver a good amount of its power because it has a good cartridge system. But yeah. Okay. Did we leave anything off? That looks pretty good to me. Any oversights you guys can see? So there is diode pads here. We're not going to do those for now. Those are optional if you want to run an inductive load. And there is a spot for a capacitor over here. That is also optional if you want, again, to run an inductive load. So the inductive load has a return capacitor on the board, basically. And if you have PWM noise, sometimes it can help soldering this capacitor on there. But for now, we're just going to leave it off. And, well, I guess we can just start plugging it in. Now, I have these plugs here, but I'm not going to use those because I actually have my power supply here, which already has those attached to wires. So let's use this one, and let's use this one. So these are the positive terminals, and those are divided over fuse 1, which is the bottom one here, fuse 1, and fuse 2, which is the this one over here, the top one. And so you have 4 positive outputs if you want to run multiple strips, and you can divide those over these fuses. Now, I recommend trying to stay within 10 amps or so of these fuses. That means 20 amps in total, or that's slightly above even what an LRS 350-24 from Meanwell can do. And that's a 350 watt power supply. And the board should be able to handle that easily, basically. So let me get some of my stuff out of the way, and then we're just going to test it. Oh, hit the microphone. I have to hit the microphone once during each live stream. Okay. How's my hot plate doing? Still warm? Yeah, lukewarm. It's okay. Can touch it. Let me clear off some stuff here. What do you guys think? Think it'll work? Think we need to rework something, or think it's just going to be fine? Is underpowering LEDs bad? How do you mean underpowering? Yeah, I like the Phoenix style too, because especially before I was using this board, and now I can just take these plugs. Done. Okay, I need to clean up a little bit. Hold on. And let me try and find the strip here, because I think I have some RGB CCT strip somewhere. So this is RGB CCT, but I think I have better. Yep. Okay. Okay. So you can use these channels for 5 times white, and I actually have that hanging here in my office. So I already have these blocks prepared, and there's 5 high power strips on here, each 20 to 28 watts a meter. That's what I use for testing, but let's not do that right now. I have this strip, which is from Gree LEDs, and it has an RGB diode, and then a warm white and a cool white. So it's RGB, warm white, cool white, or CCT, all in one strip. And then and this has a decent CRI, should have. And then we also have this kind of stuff. Let me try. Yeah. So this is also RGB CCT, but then it's all in a single package. But this is generally lower quality white light. It's okay as accent lighting, but it's certainly not suitable as primary lighting. Where this stuff, well, it can be, because these white LEDs are generally CRI 90 or higher. So yeah. So let's hook that up. Let me zoom it out a little bit. Now, the easy thing is you can just take these plugs off and then screw in the wires. Okay, so let's check on the strip what is actually the plus wire, and the plus wire is the top one. So I believe in this case the black wire is actually the positive wire. Let me get a screwdriver. And yeah, I should put wire ferrules on here, but it should be fine. And then we have, yeah, I don't know what we have. Kind of hard to see. Because there's a whole jumble of wire mess here. Let me... Oh, that's a bit dark. Okay. It's hard to see what is what. Of course, the positive is the most important. The others, it's generally okay. So maybe, let's see, cold white, warm white. Okay, so let's say that this light white wire is cold white. And it doesn't really matter which wire goes to which channel. That's something you can figure in software in the end. So then we have warm white. And I'm figuring that red, green, and blue is actually on the red, green, and blue wires. I'm not 100% sure, but we'll see. Cold white, I think the white wire, red, green, blue. Okay. I wonder how the battery of my camera is doing. It should be okay, but last time it died anyway. I mean, this camera over here. It's doing okay. We're 2.5 hours in, so... Okay, so we have that hooked up, and now we can just plug this in here. And plug this in here. And let me unspool the strip, because analog strip gets a bit warmer than digital strip, generally speaking. Okay. I'm just gonna drape it on my desk, I guess. Let's try and keep it in the shot a little bit. I don't know. Something like that. Okay, then I need this power supply. And I've doubled up on the terminals again just to make sure you can get enough current in there. But even then, this is still just 18 gauge wire, and that's plenty to carry current for this distance because it's 24 volt. Okay, so you just plug those in. Let me try and drape it a little bit more. Okay, and then we need an ESP. And, well, let's get the one I was running with, because that should be fully configured, actually. This might just work in one go. Okay, we plug in the ESP, and although my headers aren't perfectly straight, it fits pretty good. And let's get an OLED. Let's go for broke. And let's plug that in. Now, the board, the electronics, so the ESP and the OLED and stuff like that. No, the OLED, yeah, it's all fed through a PTC. So those will turn on without the fuses in there. The only stuff running through the fuses is this terminal, which is the positive terminals. So we can now turn the board on without the LEDs actually getting power to see if at least that part works, right? So let's do that without fuses. Because, you know, I'm chicken. Chicken like that. Okay. No. So, yeah, running without fuses to start, and then we'll add those later. And I think the right config is on here, but then for 5 white channels, but that won't matter right now. I'm just going to hit the switch. Hey, something's happening. So because this ESP already had a configuration, it automatically also has the OLED configuration, and it should announce itself to Home Assistant. So let me open up Home Assistant. Oh, and the orange LED works. Orange LED, orange LED, orange LEDs everywhere. Nice, and I think even the temperature sensor is working. So let me show you the window here. So we're not going to go through adding it in Home Assistant and stuff like that. I will show you the configuration in ESP Home in just a bit. But this is the configuration I already had in there. And as you can see, I can turn the channels off, and then the OLED automatically responds to that. And, you know, I can turn them all on. And even here, we can see that the temperature sensor and the humidity sensor is giving off data. Yeah, that is from right now. Is that right? Yeah, that's right. So even that tiny little temperature sensor is working. That's good. I'm always scared about that guy. But yeah. Let's do it. Whop, whop. Okay, so let's turn it off. What kind of fuses are these? 20 amp, that's a bit much. Let's use these resettable 5 amp fuses. We're not going to need 5 amp, but that's fine. Okay, that's one. Now, we only need a fuse in fuse 1 because the other channel isn't being used, because we only have a single LED strip connected, but that's fine. Okay, let's turn it on again. Oh, light. Let me wait for it to appear in Home Assistant. Okay, let's turn these off. Nice. It's working. Okay, let me drape this on here so you guys can see it better. Okay, let's just zoom it out a little bit. Okay, so we have channel 1 to 5 defined here. Oh, that's a bit much. No, too much. There we go. So let's turn on channel 1. So channel 1 is cold white. That seems to work. This is running on ESP Home right now, and I'll show you the configuration in a little bit. And channel 2. Okay, that is cool white, or warm white. But this isn't one running 100%, so let's do that. Sure, that looks good. Let me move this a little bit so you can see the OLED. Okay, let's do 3. Yep, that's red, because that was the red cable over here. That was looking good. Let's do green. Yeah, okay, that works. And then let's do blue. And then let's do all of them. Ugh! Oh, some channels aren't at full power. Let's do that. And this is using 84 watts from the socket. So running all channels at the same time is about 80 watts for this strip. And that's pretty good for that grease strip. Turning the colors off. Just the warm white and the cool white together is 50 watts. And then running only cool white is about 30 watts. And of course there's a little bit of idle draw and stuff like that. But yeah. Cool, so that works. Your face is all lit up. Yeah, probably. Yeah. Brighter than my future. What do you mean? Come on. Is Home Assistant the only way to control these? No, it actually depends on which software you flash on the ESP. Currently, we're using ESP Home. Let me show you that. So let's go to Add-ons, ESP Home, open the web interface, and then go to my test An-Penta configuration because that was already on this ESP. And here you can see my current configuration, and I'll run through that with you guys real quick. This one I have a substitution, so I can use a sort of variable, and I call that ESP home name called test-An-Penta. And then in ESP home I call it $ESP home, which then is test-An-Penta. It's an ESP32. You have to select a board, but we use GPIO pins only, so that doesn't really matter. Then I give it my secret Wi-Fi ID and password. I turn off logging because I'm using all IO pins. Sorry about that. Let me take a sip. ESP Home announces itself to Home Assistant using an API, and if that's not connected, it basically reboots the board. So I set that timeout to 60 minutes if there's a Wi-Fi interruption or something like that. I enable the web server. I use the time platform, and I ask Home Assistant for the time to display here on the OLED screen. Then I enable I2C for the temperature sensor, and it's also broken out on two of these ports here. I enable SPI because I use an SPI connected OLED screen. Then there's a little switch I use in Home Assistant. There are some binary sensors which are also exposed to Home Assistant for the three hardware debounced switch inputs. So you can connect the switch here. These are all pulled high, so you connect it to switch and to ground. And then the Home Assistant can sense that button basically. Then I define my output channels, and they're currently running at 20,000 Hertz, which should generally be enough. Then I define my lights, which are monochromatic in this case because I have 5 single color channels. We can reset this to RGB CCT in a little bit, and then you'll see Home Assistant automatically picks that up. Yeah, you define all the lights. Then I define my temperature sensor, which is that tiny little thing on the board, and I give it, temperature and humidity. Then I define some more things like uptime sensors and Wi-Fi signal just for fun. Then I do some calculation magic to make all the bars and stuff on the OLED screen happen. Let's not go into that right now. I have some more sensors which I expose, like the IP address, the SSID, and the MAC address. And every minute, this screen will flip to another page, and there it will display that information for 6 seconds, and then go back to this screen again. That's just how I like it. You can configure that any way you want to. Then I have a font that I've uploaded to the ESP. Here's the information screen real quick. But this is a font I can use on the OLED screen basically. Then it always has to start on a certain page. Then I have the interval to change those pages as I just explained. And then I have the whole display module, including pin configurations and my custom code to draw these bars and fill them and stuff like that. So, yeah. So that's the ESP home code. So I hear Johnny wants pink. Well, we can do that 2 ways. Let's go to our device. There's lots of testing devices in here. So red and blue is pink. How pink is this? It's pretty pink. How's that, Johnny? Is that pink enough? I mean, my face is pink. And these actually mix color pretty well because the diodes are pretty small. If you have a 50-50 package, that's a much larger LED than these. I don't know if they're 20-20 or 30-30 or something like that. But these are actually... let me try and focus that. They're pretty small. So the color actually blends better than on bigger LEDs. So this is red. Let's add some blue. So as you can see, that blends quite well. Let me try and show you the individual diodes, I guess. Okay, here you can see the individual diodes. And, well, they're very hard to see because, well, they're really tiny. I'm actually zoomed in as much as I can. I don't know if I can focus on this. No. There we go. So you can see those two diodes in there. They're really tiny, but they diffuse really well in the package already, basically. So, yeah, that looks very pink. Okay, let me reset the camera again. Okay. So let's do this. Let's change it to RGB CCT so we get a nice slider and stuff like that in Home Assistant. And then let's try WLED if you want. Pink, magenta, well, you can mix the colors if you want to make it a slightly different color. So maybe a little bit less blue. I don't know. Anyway, let's go back to the configuration. Hey, and we just soldered this thing together, you know, together. And we're using 5 channels. Those work. The temperature sensor worked. All the different types of MOSFET we put on here work. The OLED screen is working. The fuses work because it didn't turn on without the fuses. It all works. What do you think of that? Okay, let me copy this into a notepad real quick. Oh, and my PC hasn't crashed yet. That also works. So the only thing we need to change is we have the LED channel 1 to 5 here. I think we only need to change the light stuff. Let me look that. I have to look that up. Total success. Yes. Let me see how I do in RGB. Okay, I think it's like this. Oh wait, you can't really see my my Chrome anymore. Sorry. So let's delete this part and add this part. Okay, we don't need the light. Oh no. Okay. And then this needs to be LED channel. So we mapped it out. White was channel 1. Wait, what? White brightness, color temperature? That's not right. This is also not what I want. Ah, this is what I want. Okay. So, cold white was 1. Warm white was 2. Red was 3. 4. And 5. And this is about 2700, I think. This is, it was pretty, let's say 5500. Let's remove these. Okay, that should do it. Yeah, the OLED I have on here currently isn't ideal. I have ordered some... oh no. Oh right. Oh no, I need to change all my code here too. Whoa. Okay. This is probably going to break. Because I was reading out the LED values for the OLED part. And over time, I'm certain people smarter than me will find out better layouts and more fun stuff to do with the OLED on there. I already really like my bars and stuff. So let's see. Wireless. Yeah, okay. Looks good. Oh no. You left the one? Oh, right. Thank you. Let's see if that works. Otherwise, I just need to remove the OLED. Yeah, okay. And let's remove the OLED calculations. I'd have to rewrite that. Let's see if it installs like this. Nope, it's missing something. Yeah, it's missing everything. Okay, let's move these. I think that did it. So the OLED calculations are all tied to other stuff I had in there before. You could rewrite that, but it's not important right now. Okay, let's see if it can. Okay, it can ODA flash it. That's good. One of the other things during the design of this board, if it's booting or rebooting, there are no pins used that will create any type of flashing or PWM noise or anything like that. Because it just rebooted and it turned off the channel because, well, we changed the light configuration. But the booting didn't cause any flickering or other weird behavior. I paid close attention to that. Okay, let's go to Home Assistant. And go here, and then go here. Let's see if it picked that up. Okay, now we have living room lights. That was what it was called by default. And let's see here. Let's turn them on. Okay, let's turn them on a little bit less. Of course, don't mind the OLED. We just broke that. Okay, so it has cold white, warm white, and color. Can we turn these off instantly? No. Okay, fine. So let's turn that off. Let's make this blue. Yeah. Red. Yeah. Green. Yeah. Let's add some cold white. Okay. Let's add some warm white. Yeah. That works. Yeah, you can see all three LEDs are lit. Gwinder doesn't know who I am. What do you mean? I've seen your name before. I'm not worthy. What? Anyway. Yeah, so this is how you can create a CCT light. Now, building the whole board just to control a single CCT strip might look like a bit much. If you wanted to run lots of it, it can handle a lot of power because, well, these MOSFETs aren't even getting even warm a little bit. But it's certainly capable of that. It's maybe engineered towards running a few high power LED strips, but I did make 5 channels this time to make sure it can also run RGB CCT like this. And oh no, you can you know, play around with it. It's working well. Well, full power. Oh, that's not full power. This is full power. Ah! Anyway, that's fun. So, what time is it? It's 11:50. Do we want to flash WLED on there and give a go at that? This is in my analog LED section. I guess I can show you. Wait, let me zoom that out a little bit. If you go to analog, If you go to analog LEDs, either by the logo or the picture, and then you go down to high quality warm white, including CCT, and that category got kind of mixed. And this one is in the good quality section. And it's this one, Green Lamps RGB plus CCT with CRI 95. So it has a good color rendering index for the white. And yeah, let's see. Yeah, that's exactly this strip. So you have the RGB CCT here, and then 5 meters, 27 euros. Yeah. But then you get a high quality RGB, and even the RGB diode, I like that it's so small, but it still outputs a pretty decent amount of light, because the smaller or the closer together the individual diodes are, the more the colors will blend basically. So yeah, let me copy paste that for you. Haven't seen the analog WLED sport. Okay, sure. Let's do that. Do I take another ESP for that, or do I use this one? I don't know. So I'm not going to do anything with the OLED and stuff like that in WLED. Andy, one of the mods on Discord, has actually already made a user mod through which you can enable the OLED also on WLED. But I'm thinking about which ESP to use. Do we want to use Ethernet? We can use Ethernet. Huh? That'd be cool. Let's do that. Okay, let's turn it off. Yeah, I don't know, Aaron. Currently, there's no digitally addressable LED strip that has high quality warm white or white on it, sadly enough. But, okay. Normally we do secrets at the end, but I have been testing something. Some of you might remember that I'm making this board. The QuinLED ESP32AE+. This is a prototype. I'm hoping this will be coming out early next year. What this has, it has an IR receiver. It has a... Hold on. Nope. It has a micro SD slot. It has a digital microphone. And then it has 3 digital outputs with level shifters and resistors and stuff like that. And it's made for the QuinLED-Dig-Uno and Dig-Quad as an upgrade, so you can use any of those features. But it'll also work on this board. So now we have a 5-channel analog dimmer board, which also has 3 digital outputs. So you can run 3 digital LED strips. So you can run analog LED strip together with digital addressable LED strip on a single board. I guess that will be the secret of today. That's the advantage of creating my own ecosystem. I can do stuff like this. And of course, we still have a 24-volt power supply. But if you've been watching the channel, well, you can use 24-volt LED strip, of course. But if you've been watching the channel, you can take one of these buck converters that convert 24-volt to 5-volt, and these are 15 amp, and now you can run your digital and analog LEDs from the same board and from the same power supply. Just saying. Don't think of everything, but I do try to think of a lot of stuff. Because now and then there's people, no, 15 amps, not 50 amps. Although you can get 50 amps, but those are a bit bigger. But there's been people who've asked for analog plus digital boards in the future, in the past, and yeah, now you can if you want to. Anyway, that replaces the top hat for the Ethernet, of course, so you can't run that together with Ethernet. And there are some slight restrictions, but like, for instance, you can't use Ethernet together with the OLED because there's just not enough pins. Yeah. Anyway, let's flash WLED on here first. Do I have a USB cable? So let's install 013B6 on here. My board does have Ethernet. Let's see if it'll work without button pushing. It does. Nice. Well, 15 amps is still pretty much, you know, to run some digitally addressable LEDs. That'll allow you to run 300 WS2812Bs at RGB white maximum power with triple power injection, etc. Plenty, more than enough. Sure, yeah, you can do that with this mod. They'll have to be wireless only because, you know, the top hat replaces the wireless board basically. And it kind of use the same pins, of course. But I've been testing with the previous An-Penta prototype and that top hat, and that's been working perfectly. So in ESP Home or in WLED, you can use analog and digital LEDs at the same time, and that's been working okay. We need an ESP64 or 128 in the near future. I am actually waiting for them to release a new higher power ESP version because I'm kind of running into the limits of an ESP32. And there is an ESP32S3 now, for instance, and that is faster for some aspects, but for instance, it loses Ethernet support. Yeah, well, that kind of sucks. Okay, let's hook it up to wireless. No, let's not hook it up to wireless. Skip. Okay, cancel. Because we need to hook it up to Ethernet. Right? So let's disconnect that. Let's put it on here. Let's get my Ethernet cable. Oh! It's almost like it's designed to fit like that. So that it goes past the fuses and, you know, sits in the middle of here. It's, oh, I love design. Anyway, let's turn that on. That won't activate the Ethernet. For that, oh yeah, okay. The strip's doing a kind of weird stuff. So let me join. Oh no, let me join that wireless network. Okay, so I need to sign into WLED IP. But the only thing I'm going to do is going to Wi-Fi settings, going to down here, Ethernet type, QuinLED ESP32, save and connect. And, yep, there we go. Don't think you can see it, but if you look closely, you see that now the Ethernet port is lit up. And I need to check the IP it got. Yep, I think I got it. Okay, so this is WLED. Now we need to configure it, of course. So we go to LED preferences. Let's disable this. And we have a RGB plus CCT. That's correct. Oh, right. I need to know the pins. Oh, I should have an article for that. Let's go to my analog LED section. QuinLED-An-Penta. Pinout guide. and there is L1 to L5. So this is 14, 13, 12. Oh, 14, 13, 12. Nope. And then 4 and 2. 4, 2. Save. Okay. Let's turn this down. Let's go to black. Okay, let's show you guys some strip, I guess. There we go. Let's try red. Oh, of course. It's not mapped to... So it thinks red is the first output. Wait. It'd be nice if it said RGB cold warm, I guess. I don't know. So let's do 4 to 14, 13, 12. Still wrong, because now green is blue, blue is white. What? What's even going on? Okay, let's remove all of them. So 2. Oh, 4. Does it want it in the other order? Okay, let's go back. Red. No. Blue. No. White. Green. So green is correct. But blue and red need to be reversed. Now I can do that, I think, with this. So it's now an RGB, and blue and red need to be reversed. So it needs to be GRB. Red. No, it doesn't do that. Okay, oh god. No. Yeah, I know. So red is in 14. So I think it needs to be like this. Let's see. Why is now that on? So red is now blue. Blue is white. Oh, green is still green. What? Okay, green. Warm white. Blue. No. No. Don't do it. Okay. I'm just going to turn on white. What is 14? 14 is warm white. Right, okay. So, yeah. Okay. Then what is 13? How can 13 also be warm white? That makes no sense. I don't want to swap the wires. You can set the color order at least. I tried that, but it didn't change it seems. 12. So now warm white and red are on at the same time? That makes no sense. What? Oh, maybe because the pin isn't defined, it's doing something else with it. Yeah, the pin is just stuck. So 4 is green, 2 is blue, and 12 is red. Yes. Okay. So 12 is red, 4 is green, 2 is blue, and then we have 13 and 14. Let's try that. Red. Red lights up everything at the same time. White channel don't... Okay, red. blue, green. Okay, let's go white. Let's turn off the colors. Turn on white. And warm white, cold white. Success! Yeah, that menu system could be better. Okay, let's turn this up a little bit. So now we can do cold white, warm white, turn white off, turn on the colors, red, blue, green. Excellent! Okay, so this is also working perfectly fine in WLED, as you can see. Let's go to orange, you know, the standard stuff. Let's add the white channel, I guess. I don't know, why would you do that? Do effects work? Oh, yeah, I guess. Color loop. That was pretty neat. Color twinkles? Well, it effectively only has a single pixel, so I mean, what's it gonna do? Color waves? Fireworks. Well, it's not able to do anything. Let's go to palette. I like palette. Palette. There we go. Okay, it's gonna cycle through it. But yeah, it's able to use all of the LEDs. That's fine. You know, just it's gonna look weird for doing effects. Aurora. Okay, whatever. So, we've been streaming for 3 hours and 5 minutes, and I already, when I started this stream, I thought, okay, like, yeah, this is probably going to take like 3 hours-ish. And I guess I was pretty right on that. Let's go to warm white, and let's go full power. There we go. And let's go to neutral white. I don't know. Anyway, let's give it 5 minutes, and then we'll round off. 12:07. So we've been going for quite a while. Oh, actually, we'll go to 12:15. Then we'll have streamed at least 3 hours, a little bit more. So yeah, what do you guys think of the An-Penta board and this current prototype? As I said, some people on Discord have gotten the order link, so they have some PCBs underway, and they also have ordered all the components you need to build for it. It's not a cheap board. You need the right tools, but this is doing everything as perfectly right as I can think of, and well, it's kind of meant for that. And especially if you want to run multiple high power warm white or white strips, it's excellently suited for that. But if you want Ethernet, this is the board for you. If you want OLED, this is the board for you, except you can't use Ethernet at the same time. But it has loads of options, like the switch inputs, for instance. It has the I2C temperature sensor on there, but I2C is also broken out, so you can use extra I2C sensors if you'd like to, even add a whole load of buttons or whatever. It has extra broken out GPIO pins, depending on if you're using Ethernet or the OLED or either. Some of those aren't available. It has broken out 5 volt and 3.3 volt with at least 500 or 600 milliamps available. Yeah. Oh, Johnny asked, what are the diodes on the back used for? So indeed, on the back side here, let me remove this strip real quick. On the back side here, you can see there are spots for diodes, and there is a spot for a capacitor over here. Those are used if you're using an inductive load. Now, dimming or controlling LEDs is not an inductive load, but if you're doing anything with a motor, for instance, which can then, if you stop delivering power, basically start giving power back, that needs a path to flow to. And if you don't have diodes for that and or a capacitor, well, that could blow up your MOSFETs, basically. So if you solder those diodes and preferably also the capacitor. You can then also do inductive loads with no problem. I haven't tested that feature myself, but that should work no problem in theory. And well, this board just allows a lot more. You can use a lot of types of MOSFET, because we're slamming open those MOSFET gates with 12 volt instead of 3.3 volt. So that enables you to use a whole range of MOSFETs. I've tested a few that I had lying around and that I ordered, but you should be able to use, well, lots of different types as long as they're the same form factor. Yeah. Nico Bill says, my Penta production status changed from 68% to 73%. So a bit closer. Yay! Yeah, and well, if you want to read about it, lots of the articles are now available for it. So you can see which hardware I used. And, well, you can calculate the costs, what buying or building one of these boards would cost, for instance. Stuff like that. Backwards protection. What? Yeah, well, it actually enables a path for the positive voltage to flow back to. But yeah. Oh yeah, of course. It also has fuse protection. So you can have two fused lines and you can divide your LED strips if you have multiple over those. Yeah, lots of integrated features which I believe are useful for in a dimmer to use. And the OLED feature, for instance, is on there because I like seeing my dimmers and then being able to see the status at a glance, or being able to see its IP address or something like that, for instance. Thank you for a generous tutorial. This device is fantastic. Great to have at home. Thank you, Victor. So, any questions? No 8-bit. Actually, we're doing 12-bit dimmer. 11 or 12-bit? Give me all the colors. Aaron says, whoa, you're in the future, so Merry Christmas officially, Quindar. That is right. It's 12/12, so Merry Christmas to everyone. Not sure if I'll be releasing, I will be releasing a video at least next week. Not sure if I'm doing a live stream. Flyback diodes, yeah. Freewheeling, flyback, whatever you want to call it, yeah. So, when will the pre-assembled one be available? That's a good question. I first worked on getting this DIY version made and tested and stuff like that. And although I can reuse most of the circuit of that, so the schematics basically, I will be redoing the board layout because I don't have to use 0805, I can use 0402. And there need to be some other changes. For instance, on a pre-assembled board, I wouldn't be using these pre-assembled buck converters, for instance. I'd be using my own buck converter layout and stuff like that. Of course, I first have to design that and I have to test that, and yeah, so that'll be a little while, but I'll be working on it, that's for sure. How fast can I do PWM? In theory, what I've tested and checked on my oscilloscope, it should have no problem, and the theory behind it also calculations, it should have no problem doing 300 kilohertz. And I basically haven't tested it above that. Can you show your digital LED hooked up together with analog? Sure, but we might make that another stream, I guess, once that other board is released. Not right now. I hope you can make a special edition for the WLED software for your boards. What would you like to see in a special edition, Sevag? I mean, it's doing everything right now. Hey, we also passed the 3-hour mark of the PC not crashing. That's good. Where is the 12 volt used for? The 12 volt is used for the MOSFET gate drivers. So the MOSFET gates are getting 12 volt instead of 3.3 volt. And if you use 12 volt LED strip, the 12 volt regulator won't give off 12 volt. It'll give off 10.5 volt. But that's still way higher than 3.3 volt. So that should generally be fine. And I have also tested that. And currently I've tested the board up to 20 amps. And it did that perfectly fine, especially if to spread the load over the MOSFETs. I've loaded a single MOSFET up to 10 amps, and that's been fine. It gets 60 to 70 degrees, but that's okay. Yeah. Do you have any tips to do a 105 meter pixel strip setup? Yeah, look into buck converters and 24 volt. Or maybe just go to 24 volt LED strip, I guess. But then still 105 meters is insane. I'd make that multiple controllers and sync those. No logic level FETs. Well, these are still logic level FETs, but they will still work better with a higher gate voltage, because then they'll just get less warm. And they also get a really fast gate charge. But you can indeed use higher voltage, gate voltage MOSFETs now, because you always have the 10 to 12 volts. May you please post this stream on YouTube? All my stuff is on YouTube. Non-logic level MOSFETs tend to have a much lower RDS on. Yeah, well, the 8447Ls I like using, which I also use in my previous designs, those only have like 6 milliohms, I believe, so really low. But yeah, I still plan to buy like a bunch of MOSFETs and just test them out, I guess. Are special tools absolutely necessary for the DIY An-Penta? I'd say you can do it with hot air, except for the temperature sensor probably. So if you have a hot air soldering gun, you'll probably be able to build all of the board except for the temperature gun. For the temperature sensor, because it's just too small and only has pads beneath it, and you'll probably melt it before you solder it. So I'd really advise the hot plate, but I'd advise the hot plate for this board anyway, because, well, as you were able to see in a live demonstration, it makes it very easy to do. You just put paste on there, you plug the components on there, you put it on the hot plate, you wait for it to reflow. We had 0 solder bridges. We soldered on all the through-hole connectors, done. I mean, in that regard, I actually like SMT or SMD more than I like through-hole, because it's actually easier, in my opinion. So, yeah. I think this board takes us to the next level. Well, that's what it's designed for. The other boards, the quad or the An-Quad, I've renamed them, the An-Quad and the An-Deca weren't bad. They were just simple, designed to be simple, and to be simple to build, to be simple to understand, to be simple to use. This board is on purpose more advanced. It has gate drivers, serial resistors, all kinds of voltages going on the board, 4 layers. It has onboard fuses, and there's a lot more stuff going on, basically. But yeah, that, you know. Sure, for a few bucks extra, I would opt for the assembled version. I get that. Some people find it fun to build these projects. That's why I do the DIY stuff, because I know how that feels. I started like that too. I mean, I don't make a lot of money on... Well, I don't make a lot of money on pre-assembled stuff either, but I certainly don't make a lot of money on DIY stuff. Especially this board, because this doesn't even have much or any Aliexpress links, so there's no affiliate income either, because LCSC doesn't do affiliate income. So, yeah. But I hope people, if they really use the board, I hope they'll donate a little bit and have fun building it. But then there will be a pre-assembled version, which basically has the same features. I'm not 100% sure yet about the same layout, because I might want to offer it with a case. But it'll basically have the same features at least. Oh, Gerard missed the beginning, so we will catch up on YouTube. I wanted to say Merry Christmas and thank you for the help the other night with the Dig-Quad. Sure, no problem. Oh, Johnny says, thanks for the live streams during 2021. Much appreciated. Also, SEKS rules. For sure. So, I think, oh, we're already over. It's 12:19. This has been a long stream. This has probably been the last stream of this year. Although, who knows how I'll feel next week, and I might just hit that button again. But I thank everyone for watching, as always, and I hope to see you back in another live stream on the Discord server in the videos, in the comments, or, well, online. Bye-bye.